This video is about finding zeros of a polynomial. There's the rational zero theorem that will tell us how to find rational zeros. And I know from last lecture, 3.3, we saw that you can use a graph and therefore the graphing calculator to find zeros. If you don't have a graphing calculator, this is the theorem that you can use to find the possible rational zeros. So to find the possible rational zeros, we want to find plus or minus the factors of the last number. Okay, don't take the sign. And that's going to be the constant because it needs to be in descending order. Over the factors of the first number. Which is called your leading coefficient. Okay, so we have the constant over the leading coefficient. So in this example, it's plus or minus, because it could be a positive or negative number. Factors of 15. Notice I'm not taking the sign because the sign will get picked up with using the plus or minus over factors of 4. So you have plus or minus 1 times 15. 2 doesn't go into 15. 3 times 5. And the number between 3 and 5 is 4. But 4 does not go into 15 equally. So how do we get 4? 1 times 4. 2 times 2. So when we list our factors, we take the number in the numerator or on the top, and it has to make a fraction or it's going to write a ratio with every number. So it's going to look like this. Plus or minus 1 over 1, 1 over 2, 1 over 4. Plus or minus 3 over 1, 3 over 2, 3 over 4. Plus or minus 5 over 1, 5 over 2, 5 over 4. Plus or minus 15 over 1, 15 over 2, 15 over 4. So depending on how these are written out, let's go ahead and simplify. So it's plus or minus 1, 1/2, 1/4. 3, 3/2, 3/4. 5, 5 over 2, 5 over 4. 15, 15 over 2, 15 over 4. And if I'm going to list all of them, I would list all the terms positive and all the terms negative. But for these purposes, we are just going to list it with the plus or minus. So again, remember, plus or minus means that it could be a positive or a negative number. So if you count, there are 12 of numbers right here. And if you list the 12 positive and 12 negative, there's a possibility of 24 rational zeros. Notice that this is not going to include the irrationals or the imaginary or complex numbers. Okay, so how would that help us? Well, we have to find the zeros and their multiplicity. Okay, so what I would do is I would use a graphing calculator. We could make a list and guess and then do synthetic division until we found the right answer, but the graphing calculator is just a little bit quicker. Okay, so the calculator gives you the number 5 as a 0. So our next step is to do synthetic division. Because if you remember, when it's a 0, the remainder is 0. So I'm going to put a 5 here. And I'm going to use 1, negative 2, negative 14, negative 5. So again, I know my remainder is 0. If I don't get a 0, I've made a math error. Bring your 1 down. 5 times 1 is 5. Add down, you get 3. 5 times 3 is 15. Add down, you get 1, 0. So you are left with x squared plus 3x plus 1. You want to set that to 0. Now, that cannot be factored. So we can use the quadratic formula. A is 1, B is 3, C is 1. And then I like to find b squared minus 4ac. That way I can replace b squared minus 4ac with one number. So that's 3 squared minus 4 times 1 times 1. That's 9 minus 4, which is 5. So let's review the quadratic formula. X equal opposite of b, plus or minus square root b squared minus 4ac all over 2a. X is equal to negative 3, plus or minus square root 5 over 2 times 1. X is equal to negative 3, plus or minus square root of 5 over 2. Don't lose that square root there, because there's a difference between the number 5 and square root of 5. This is called exact form, so there are two answers. Actually, let's look back at the original. And if we look back, it was x to the third. So there's 3 answers. So the answers are the 5 from the calculator, and then from our work here, negative 3 plus square root of 5 over 2, and negative 3 minus the square root of 5 over 2. Okay, number 3, we're going to do the same thing. Find the zeros in the multiplicity. Now, I forgot to review this. The degree is the largest exponent, so it's 4. So this means there are 4 answers. You can have an answer repeat, but I have to have 4 answers. So the degree gives us the number of zeros or answers to these functions. Okay, so this means that there are 4 zeros. So again, using the graphing calculator, we are going to get negative 1 and positive 1. We must do synthetic division. The order that we do our synthetic division does not matter. And I know because I have 2 zeros, I'm going to have to do 2 synthetic division problems. And then we'll do quadratic formula, go from there. It doesn't matter which number you want to divide first. Let's just do the negative 1. Okay, so we've got negative 1. We have 2, 1, negative 5, negative 1, and 3. Coefficients from the dividend. Bring your 2 down. 2 times negative 1 is negative 2. Add down. Negative times negative is positive. Negative 4, 4, 3, negative 3, 0. Now, this leaves you with 2x to the third minus x squared minus 4x plus 3. That is now the new problem you have to solve. Do not go back to the original problem. If you do, you'll miss it. So now we want to use the other number, which is positive 1. And we're going to do that with our new problem that we found. 2, negative 1, negative 4, 3. So that's the quotient or the answer to the first division problem. Bring your 2 down. 1 times 2 is 2. Add down. Get it 1. 1 times 1 is 1. Add down. Negative 3. 1 times negative 3 is negative 3, and you get your 0. This leaves us with a quadratic. 2x squared plus x minus 3. Now, if you think about it, 3 minus 2 is 1. I can get a middle term. So I can factor a little bit by guess and check. Okay, if I put a 3 here, I get a 6. That's too big. So what I'm going to do is I'm going to put a 3 here and a 1 here. So when you multiply, you get 2. So we need a negative sign here and a positive sign here equals 0. So 2x plus 3 equals 0. Or x minus 1 equals 0. Subtract your 3. 2x equals negative 3. Divide by 2. X equals negative 3 over 2. Add 1. You get x equals 1. Now, originally, this was an x to the 4th. I should have 4 answers. So, what are my answers? So, actually, we're asking for the zeros. So, what are my zeros? So, your zeros are, from the calculator, 1, negative 1, negative 3 over 2, comma 1. Notice the 1 is repeated. That means 1 has a multiplicity of 2 because there's 2 1s. It's repeated. Okay, let me spell multiplicity correct here. Multiplicity of 2. And then the negative 1 has a multiplicity of 1. And the negative 3 over 2 has a multiplicity of 1. So again, notice there's 4 zeros with 1 repeating. Okay, so I mentioned this earlier. The fundamental theorem of algebra says that if your degree is greater than or equal to 1, then you have to have at least one complex zero. So if you guys recall, the complex zero is of the form a plus bi. So real numbers are complex, imaginaries are complex, a plus bi form is complex. The number of zeros here has to be n complex zeros. See, n is your degree. So number 4. Given this is a solution, so I'm telling you negative 1/2 is a solution, find the remaining solutions and write it as a factor. So we're going to find the remaining solutions and we will write our answer in factored form. Okay, so notice again, it's x to the 4th. I know I'm going to do 2 synthetic division problems unless I can factor. So let's look at the fraction, negative 1/2. Okay, coefficients for, I'm looking at the exponents on the x term. So you have x to the 4, x to the 3, x squared, x and number. So you're good. You don't have to have any zeros as placeholders. 2, negative 1, 17, negative 9, negative 9. Bring your 2 down. Negative 1/2 times 2 is negative 1. Add down. Negative 2. Negative 1/2 times negative 2 is 1. Add down. Negative 1/2 times 18 is negative 9. Add down. Negative 18. Negative 1/2 times negative 18 is 9, and we get a 0. So it was an x to the 4th. This gives us 2x to the 3rd minus 2x squared plus 18x minus 18. Now, because the 2's are the same coefficient for both terms, and the 18 is the same coefficient, I think I'm going to try to factor this. Anytime you have 4 terms, you factor by group. So you have 2x squared times x minus 1 plus 18 times x minus 1. So that gives us 2x squared plus 18 times x minus 1. And I notice I have a GCF. I should have taken the 2 out. So let me go ahead and factor out the 2 here. And let's see. It asks us to write our answer as a product of linear factors. It also asks us to find the remaining solutions. So, to get our answers, we have to set these terms equal to 0. So x squared plus 9 equals 0. Let's review what's called the square root method. Subtract 9. X squared equal negative 9. Square root both sides. X equal plus or minus 3i. X minus 1 equals 0. X equals 1. So your solutions are the negative 1/2 that's given, plus or minus 3i and 1. So we have x equal negative 1/2, x equals 3i, x equal negative 3i, and x equals 1. So to get our factors, if we move this over, we have x plus 1/2 equals 0, x minus 3i equals 0, x plus 3i equals 0, and x minus 1 equals 0. All right, so you don't want a fraction in factored form. I'm going to multiply by 2, so I get 2x plus 1 equals 0. So again, let me show you what I did. I multiplied each term, each side here by 2 to clear our fraction. So we multiply by 2. Okay, so your answer is, well, here's our solutions here. And let me show you the factored form. So the factored form answer is, you would say 2x plus 1 times x minus 3i times x plus 3i times x minus 1. Now if you notice, the exponent on each x term is 1, so it has multiplicity 3. So go try your homework and have a great time at math.